Hello, and welcome to 8.4 Inverse and Solving Logs/Exponential Equations. So we're going to start out with a quick review here of how to evaluate logs without a calculator. Remember, for these we want to set them equal to x and then rewrite it in the opposite form. So log base 4 of 16, we set it equal to x. We're going to take the 4, swing it underneath here, we get 4 to the x equals 16. And now here we can just recognize that, we can write 16 as a power of 4 because there's two groups of 4. So 4 to the x is the same as 4 squared. Therefore, our answer is 2. Here's the next one. Set it equal to x. Swing the 2 under the x. So 2 to the x equals 8. 2 to what power would give us 8? And the answer here, if we break this up, 4 and 2, 2 and 2, we'd get 2 to the third power, because there's three groups of 2. So x equals 3 is our answer on that one. Now when we go in reverse, we do have to be careful. So when we have log base 8 of 2, we would swing this over. So it'd be 8 to the x equals 2. And now we want to break up our 8 instead. And we just saw this. It was the same as 2 cubed. So if we write this as 2 to the 3x instead of, because we know 2 cubed is 8, then we can set this equal. And if you want, you can even think about, 3x would have to equal 1 now that we have the same base. 3x equals 1, divide by 3. We get x equals 1/3. Which also makes sense because the cubed root of 8 equals 1/3. And we could have skipped this step. We could have recognized, there's 3 2's, and I know if I'm going from a big number to a small number, it's going to have to either be a fraction or a negative exponent. So the 1/3 answer makes sense here. Okay, I'm going to do this one over here. Log base 4 of 1/2. We're going to set that equal to x. We're going to swing the 4 over. So this is 4 to the x equals 1/2. These ones are always tricky because there's two things going on here. We're going from a 4 to a 2, so the number is getting smaller, and it's also going from a whole number to a fraction. So in that case, we know that our answer has to be a negative number in order to get the fraction part. So we can think of this as the same as two groups of 2. So 2 to the 2x equals, and you could write 1/2 as 2 to the negative 1 power. If you wanted to, you can set these two equal to each other. Say 2x equals negative 1, divide by 2, and we get an answer of negative 1/2. Okay, which also makes sense because the square root of 4, which is the same as taking 4 to the 1/2 power, and then flipping it from the negative, would get us to 1/2. Last one here. This one we're going to set equal to x, and be kind of careful here because we see an extra number, but that's just the exponent of our 3 here. So this would be 3 to the x equals 3 to the 1/4. And since our exponents have to be equal since our bases are the same, we can conclude that x equals 1/4. All right, so that's just a quick review of the logs and how we can evaluate without a calculator. Now let's get into the inverses. This is the new part of our lesson today. So log and exponential functions are inverses of each other. We're always allowed to rewrite them in the opposite form. But if we do the composition of them, we end up getting x. So they're inverse functions. Basically, they undo each other. So log base b of b to the x equals x. Because if I were to rewrite this in exponential form, b to the x equals b to the x. So in that case, our answer would just be x. But notice how log base b of b, if these are matching, then your answer is just the exponent. Same thing happens if you take a base of log b to the x, because we could rewrite this in the log form. So remember, to write it in the log form, you take your log of our base, which is little b, and then our exponent is right here. So that's what goes, log base b, log, should be b to the x, equals this exponent right here, log b of x. So if these match, it essentially just leaves you with the term next to the base, which is x, and that's why our answer ends up just being x. But what they do is they undo each other. So I know it's kind of weird right now since we're just using variables, we can't actually see it with the number process. It'll make a little bit more sense once we use numbers for it. But just understand that when the bases match, or you're taking the log of base b of b, you're just going to get the exponent. Same thing when you take the exponent to a log like what we see over here. So here's some examples. We have 10 to the log 10 power of x. So in this case, because our base matches the log, we're going to assume this is a common log since we didn't see a number. This part here would just go away, and it would give us x. Over here, this one's a little bit more complicated because it's log base 5 of 125 to the x power. We would probably want to rewrite this one, so let me use a different variable. So I'm going to say that this one equals y. So this one would be log base of 5 to the 125. We're going to swing this over. 5 to the y equals 125 to the x power. And then this one we would have to rewrite it because 125 is the same as 5 cubed. So let me rewrite this part. So this one's kind of an unfair problem because the bases weren't the same. Like we didn't have 5 and 5. So not our best designed problem here, but this would just state that y would equal 3x since our bases are now the same. Okay. Now these ones here, we want to try to write the inverse function or find the inverse. Remember, when we learned about inverses in the last unit, what we did to start out is we switched our x and our y components. So I'm going to rewrite this as x equals the log base 8 of y. Now, whenever you're starting out with a log function, you want to write it in the exponential. So what we do is we take our base, we swing it to the exponent, we would get 8 to the x equals y. And it's magic because just like that, we were able to get y by itself by rewriting it in the opposite form. And that would be the inverse of our original function. Same thing over here, y equals the natural log of x minus 3. Make sure to note that this is in parentheses. That does matter for the order here. So we're going to swing our... Oop, I forgot to change my x and my y before I did that. So x equals the natural log of y minus 3. Don't forget your e there. And now I'm going to rewrite it after I switch my x and y. So this would be e to the x. The natural log is now gone, and it's just left with y minus 3. And then we can add 3 to both sides because we're trying to get y all by itself. So e to the x plus 3 equals y. The solving steps for these ones is probably even easier than the inverse functions we did before. But this is how we're actually going to solve them too. Rewriting them in the inverse form, and then the answer should just be a lot more clear after that. So here's some examples. We don't need to go through every single one of these. I'll just pick a couple. So remember, always start out by switching your x and your y. Log base 9 of y. Swing the 9 over. So this one would be 9 to the x equals y. And just like that, we have our answer because we have it solved for y. Let's do one like this, though. This one's a little bit trickier. So this one would be x equals log 749 to the y power. So here, when I rewrite this one, I'm going to swing this over. We get 7 to the x equals 49 to the y. Okay, now this one, oh wait, what happened here? Why is this one not working as nicely? Actually, let's start over on this one. This one we have to start out by rewriting this whole thing as x equals log base 7 of
7 to the 2x, or sorry, 2y. Now the reason I had to rewrite it like that is because the log, like these two have to match in this instance since we have an exponent up here. So this one's log base 7 of 49 to the x power. So I just rewrote it as 7 squared, which is the same as 49. And now since these match each other, technically it's just going to be the exponent. So this means that x equals 2y, we can divide by 2, and we would get y equals x over 2. Okay, that one's kind of a complicated one. You're not going to see that one as much, but let's go ahead and look at the next one here. Okay, this one is very similar to the one up above. I want to do a different one here. Let's do this one right here. Log, or the natural log of x plus 2, so that would equal the natural log of e to the y plus 2. We take the e, we swing it over, e to the x equals y plus 2, and then we just subtract 2 after that. E to the x minus 2 equals y, and there's our answer. So these other ones are very similar. I don't think I need to go through a lot of that. Now we're going to move on to the solving aspect of this, which still has to practice the rewrite like what we're doing here with the inverses. Okay, so solving exponential equations. If two powers with the same base are equal, then their exponents must be equal. We saw this up above too. This isn't really a new concept. You've practiced this a few times already. But just note that because the 2's are the same, then the exponents would be the same. So therefore x would have to equal 3. That's the only way to balance the equation. The same is true when we're talking about exponents. Oh, I need to teach you the change of base formula, because that's going to be a part of our solving. So the change of base formula okay, let's say that this is the same as log base b of a is equal to the log of a divided by the log of b. So we take the log of our number here, which in this case is a, divided by the log of b. And you can just use the common log button for your calculator. So what we can do here is instead of a and b, we can think of this as our a, this is our b. So we can take the log of 8 divided by the log of 3. Let me just pull up my calculator here. And then when we type this in, log of 8 divided by log of 3, we get 1.89 if we round that to 2 decimal places. So 1.89 would be our answer. Same thing over here, log base 4 of 15, we can rewrite that as the log of 15 divided by the log of 4. And it comes out really close to 2, which makes sense because we know that 4 squared is 16. So if we're trying to go from 4 to 15, it's got to be slightly smaller than 2. So then our answer would be 1.95 here. But it's pretty efficient with the calculator. Now we're going to go back to some different types of solving. Some will require the calculator, some won't. So these ones we can do without the calculator for the most part. These ones, since we have the same base, we can assume that our exponents have to be equal. So all you'd have to do here is set them equal to each other. 6x equal to 3x plus 3. Subtract 3x. 3x equals 3. Divide by 3. And we get our answer of x equals 1. Really nice answer. Nothing too complicated there. Just note that our bases had to be the same in order to set them equal. So the same thing happens here. We have 10 and 10. Therefore, the exponents have to be the same. So to solve for our variable here, we just set them equal and solve. So subtract 2x. I'm going to add 1 to both sides. We would get 4 equals 2x. Divide by 2. And we would get x equals 2 here. Now, there's no restrictions on what we can put into an exponential function. We can plug in any number for x. There's not going to be any restrictions there because we've seen that with the graphing. That's why the domain is all real numbers, goes from negative infinity to positive infinity. Be really careful on these ones because 4 and 16 are not the same number, but we can always write 16 as a power of 4. So we know that 4 squared is the same as 16. So if you just rewrite it in a more familiar way, then we get the same base, and now we can set our exponents equal. So 2 is equal to x plus 1, subtract 1, and we can say that 1 equals x, or x equals 1. So these solving ones are pretty straightforward, nothing too crazy here. The same is true for logarithms that have the same base. If they are equal to each other, you can just take the pieces inside the parentheses, if you want to think of it like that. But if we know that we have a natural log, we assume that the base is e for both of them. Therefore, this part of the log has to be equivalent on both sides. So we can assume that 2x plus 3 is equal to 5x minus 6. So we would subtract 2x. We would get 3 is equal to 3x minus 6, add 6, 9 equals 3x, and then when we divide by 3, we get x equals 3. We do actually have to check for extraneous solutions, because if you recall earlier when we first learned about logs, you can't take the log of 0 or anything less than that. We are restricted. This is where like the asymptotes on our graph would come in, which we're going to see in the next lesson. But in this case, we can't take the log of 0. So it has to be, our answer would have to be greater than 0. We can't take 0 or anything smaller like a negative. So if we plug in 3, this is our check process, we would get the natural log of, it would be 2 times 3, which is 6. 6 plus 3 would have to equal the other side, the natural log of 15 minus 6. So we'd get the natural log of 9 equal to the natural log of 9. That's a good solution. It works. Let's do the same thing here. We can assume that these are common logs. So now we're allowed to set the pieces next to the log, or next to the base, equal to each other. X plus 3 equals 3x plus 1. I'm going to subtract x. I'm going to subtract 1. We get 2 equals 2x, divide by 2, and we get x equals 1. And because we're adding with both of these, if we plug in 1, you'd get 1 plus 3, which is 4, and then you'd get 3 plus 1, which is also 4. So we can assume that that is correct. On to the new part. So these are going to look a little intense, but after you practice a few of them, they're not so bad with the solving. Our goal is always to isolate the base with the exponent, if we're talking about an exponential equation, and then rewrite it in the log form, and it should be a lot easier. And we're going to use our calculator for a lot of these. So this one, 5 to the x power, that would have to be a decimal because there's not a nice way to go from 5 to 8. So if we rewrite this as a log, it would be log base 5 of 8 equals x. This is definitely a calculator problem. So we're going to go to our calculator here. I'm just going to leave it up because a lot of these are going to require the calculator. Log, and we would have to type in the log of 8 divided by the log of 5 because we are trying to use the change of base formula. And that comes out to be 1.29. So that is our answer on this one. Definitely not one we can solve without a calculator. But the exact form of it would be this, log base 5 of 8. Next one, again, we want to isolate first. So let's add the 6. We get 10 to the 2x equals 152. Then we should rewrite as a log, because we're going to get stuck here. We don't know what 10 to some power equals 152, and we can't rewrite 152. So if we rewrite this as a log, it'd be log base 10 of 152 equals our exponent, 2x. And then whatever that decimal is that we get from this here, we're going to divide it by 2 to get x by itself.
So type in log of 152 divided by the log of 10, and then whatever that is, we're going to divide it by 2. Oop, I forgot my divide sign. And then we are going to divide once again by 2. And it comes out to be 1.09. We can round this one to. So x is equal to 1.09. Again, the reason I divided by 2 at the end here is because it's 2x. So we got to get the x by itself. Here's our next one. Whenever you see an e in the equation, you can assume that you're going to work with a natural log. Just makes it a little bit easier. This one, though, if we rewrite it, we'd have the natural log of e, and then it'd be 5 equals negative x. So here we want to type in the natural log of 5, which is nice because we don't have to do a change of base formula. You can just type in the natural log of 5. And that comes out to be about 1.61. Divide by negative 1, and we get our answer of 1.61. Oh, negative 1.61, excuse me. Okay, here's this one. We're going to subtract 9 because we want to isolate the e to the x part. So it would be negative 4, e to the x equals negative 4. We're going to divide by negative 4. We're going to divide by negative 4. We'd get e to the x equals 1. And at this point, it's not necessary to rewrite it because we can assume that we know what would happen. But I will show you how to rewrite it for the sake of solving this. If you remember, anything to the 0 power has to equal 1. So we can already assume that x is going to equal 0, but I'll show you it with the log. So if we rewrite this as the natural log of e of 1, that's going to give us our answer. Watch what happens when I type in the natural log of 1. We get 0. So that was correct. All right, the last part here is, well, what if we have a log and we don't know how to solve for x when it's inside of the log? Here we want to do the exact opposite. We want to isolate the base with the exponent. In this case, we want to isolate the log, and then we want to rewrite it in the exponential form, then maybe use our calculator if we need to. So this one, we would swing our base over. It would be 5 to the 6th power equals x plus 2. 5 to the 6th power is a big number, but fortunately we get a calculator for this one. Come on. Ends up being 15,625 equals x plus 2. We're going to subtract 2 from both sides. And we get 15,623 is our answer on that one. Next one, remember if it's a natural log, assume that it's base e. Swing that over here. This one would be e to the 5th equals 2x. We have to divide by 2. And e to the 5th is just a decimal number, so we can type this in our calculator. I'm going to get my e button to the 5th power. And then I'm going to divide by 2 at the end. And it comes out to be approximately 74.21. You can assume that we're going to round it 2 decimal places for most of these. Next one, we have log of x plus 4 equals 2. If we don't see a number and it's a regular log, assume it's the common log, so we can assume this is base 10. We're going to swing this over. 10 squared equals x plus 4. 10 squared is the same as 100. So then we can just subtract 4. We get 96 equals x. And that was the last one. These ones are pretty straightforward because you're just rewriting it in the opposite form. So just remember, whenever you're solving, if you get stuck, if you're in the log form and you get stuck, write it as an exponential. Or if you're here, it's in the exponent form and you're stuck, rewrite it as a log, and you can likely type it in your calculator or just know the exact answer for it. And that is it for this one.